Welcome students, I am Adlin lecturer of Isomerism College of Pharmacy. Today's topic is Isomerism. First we see the introductions about Isomerism. Isomerism is inorganic organic chemistry. It's a phenomenon shown by two or more organic compounds having same molecular formula but different properties due to difference in arrangement of atoms along the carbon skeleton or in space. What is meant by isomers means isomers do not necessarily share similar properties unless they also have the same functional group. The isomerisms are two main forms of isomerism. First one, structural isomerism, that is also known as constitutional isomerism. Second one, stereoisomerism. The stereoisomerism is also known as spatial isomerism. This is the two main forms of isomerism. Next we see the classifications of isomerism. The isomerism is classified into two. First one, structural isomerism. Second one, stereoisomerism. In structural isomerism, they are classified into 5-6 types. First one, chain isomerism. Second one, positional isomerism. Third one, functional isomerism. And fourth one, ring chain isomerism. And fifth one, metamerism. And sixth one, tautomerism. These are the structural isomerism. Second one, stereoisomerism, is classified into two. There are geometric isomerism and optical isomerism. These are the classifications of isomerism. Next we see the first one, sexual isomerism. They are classified into 6. First one, chain. Second one, positional. Third one, functional. And fourth one, ring chain isomerism. And fifth, metamerism and tautomerism. These are the types of isomerism. First one, chain isomerism. The same molecular formula represent two or more compounds and it differ in the nature of carbon chains. For example, butane. Butane is the chain isomerism example. Second one, positional isomerism. In positional isomerism, the same molecular formula represent two or more compounds. It differ in the position of the same functional group. That is called positional isomerism. Example, butene has two isomers, namely but1ene and but2ene. This is the position to change the position. That is called positional isomerism. Butane 1ene and butane 2ene is the example of position isomerism. And third one, functional isomerism. Functional isomerism means the same molecular formula represent two or more compounds and it refers in the nature of the functional groups. For example, propanoic acid and methyl ethanoate is the examples of function. The functional group is different but the molecular formula are same. That is called functional isomerism. The propanoic acid and methyl ethanoate is the examples of functional isomerism. Next, fourth one, metamerism. Metamerism means the same molecular formula represent two or more compounds and differ in the nature of the alkyl groups attached to the same functional groups. Metamerism means the functional group is arrangement is different places but same molecular formula. That is called the metamerism isomerism. And as example, diethyl ether and methyl propyl ether is the example of metamerism. Next, sixth one, tautomerism. It also same molecular formula represent two or more compounds. It exists in dynamic equilibrium with each other and it can be present in many forms such as nitroform and acidiform and ketoform and enolic forms, etc. These are the forms present in these structures. Examples, nitroethane is a nitroform and isonitroethane is an acid form. This is the examples of tautomerism. These are the classifications of stereoisomerism. These examples of structural isomerism. Next we see the stereoisomerism. So, classified into two. That is, one is geometric isomerism. Second one is optical isomerism. This isomerism differs in the spatial arrangement of atoms or groups. That is called stereoisomerism. Two types, one geometrical and optical. First we see the geometric isomerism. Geometric isomerism means the same molecular formula represent two or more compounds. That is called Geometrical isomerism. It differs in the spatial arrangement of atoms or groups around carbon-carbon double bond. It differs in spatial arrangement of atoms or groups around carbon-carbon double bond. It is two types. If the same group are on a same side, then it is called cis. But an opposite side, that is called trans isomerism. Examples of geometric isomerism means first one 6,2-butene and trans-2-butene are 6 trans isomers. This is the examples of geometrical isomerism. Next we see the optical isomerism. Optical isomerism means when light is when plain polarized light is used, that is called optical isomerism. Optical isomers are named like this because of this effect on plain polarized light, so its name is called optical isomers. Optical isomers, which are non-superimposable mirror images of each other, are called enantiomers. Optical isomerism contain anti-clockwise direction and clockwise directions. Example: dextroaniline and levoaniline and lactic acid are the examples of optical isomerism. These are the classifications of stereoisomerism. These are the classifications of isomerism. Today we see the definition about the isomers. Next we see the classification of isomers. There are two types: structural isomers and stereoisomers. Structural isomerism means they are same molecular formula but different structure, that is called structural isomers, that are classified into 6 types. First one chain isomerism, second one position isomerism, and third one functional isomerism, and fourth one ring chain isomerism, and metamerism and tautomerism. Stereoisomerism are classified into 2: geometric isomerism and optical isomerism. These are the classification. Today we see the briefly. Thank you.